Alright, so let me first talk to you about this website right here, classes.yale.edu/fractals. That's the actual Dr. Mandelbrot set.
There was a fractal on the SAT this weekend.
Oh yes,
There was a fractal on the SAT.
Yes, I
I was
heard.
like, oh my god, I know this. Like, I see it.
But it was
Yeah,
easy. I mean, that. What did I ask?
It didn't say it was a fractal. It just looked cool.
Okay, what's the perimeter of a one side? Was it a whole side?
I think it was like 3 iterations.
Oh, that was too easy. They should have asked me the eventual.
It's not even funny.
No, because the answer is so obvious. Answer is so obvious. It's like, it's intuitive. It's like you get it.
I was so happy. I was like,
All three of us were made there, and you just have remained in like.
Mods?
Yeah.
Raise your hand if you do a test on first.
I just wrote a program to kind of really easily. Everyone else hasn't checked it.
Good. Alright. Well, you better not do that for the test. Test on Wednesday.
Yeah.
Wednesday or Thursday. Alright. So, you guys have a test Wednesday AP. Alright, so what I'm going to teach you today is how to use this particular software. So when you go to this website, as I told you, Dr. Mandelbrot passed away in 2010. He taught at Yale until his last days. And this is a website, that has a lot of stuff, which is actually always taught in Yale under math department. So if you were looking into this, I mean, this is like a great resource for dynamic system, and also great resource to research people. Pick any topic on these and just it's so nice. And very interesting and applicable, and programming on it, you come up with awesome pictures. You can come up with, very good sound mathematics out of it. We can come up with models, 3D models for it. Which, by the way, I'm giving extra credit for people who wants to 3D fractal figures, like so just this triangle. Yeah, something like that. I'll show you like. No, not a maximum of 3 in a group if you want to do that. So what happens? Maximum. No, as in you could do more, but yes, you have to certainly do more. What? We can make one. I mean.
How many iterations?
You know what? I'm gonna choose the best one. And they give that more. Actually, how many?
yeah.
Fractals.
Obviously, you're looking at 3D fractals because.
Oh my goodness, so high. Oh.
You see that?
Why is it a... We have to do after.
Yeah, so I'm thinking of assigning this.
How about we make it do like
Towards the, I will give you at least a week after the AP is over, a week or 2, so that you will have more time. And if you need like materials, you probably sometimes can't get or out of like order online or something. I'll give you time for you to prepare. So something like that. Look at that. 3D Sapinski's triangle. Do whatever you want. Okay, so that's some like that. No, you can do whatever you want. This I like this one too. Sponge. Cube. Sapinski's cube. I've also seen, do you know this one right here? Yeah. So you can do that if you want. Make a cube if you want. Look at that. That's pretty nice. And if you want to do, whatever you want to do, just think about it, and I will give you, what's that? I don't know. It looks like, no, it looks like rice cereal. You eat it. Haha. That's lame.
Oh, Minecraft fractals.
Minecraft.
Actually, make it in Minecraft and then, like, take a video and send it to you.
No, I want a 3D model.
But Minecraft isn't. I'll make something insane in Minecraft.
You see that? It's one of the, I bet, for math fair. They actually made pretty large. This triangle in 3D. So if you want, hey, if you have other ideas, come by, run it by me, and I'll approve you're good, and I'll, because I don't want something, I'll, at the end of the construction, give it out. I mean, obviously, bigger the better. Yeah, but don't do like one iteration.
I'm gonna do that.
At least like 3. Yeah. At least 3 or 4. Oh, look at that. Look at that. Oh, this is cool. These are all different polyhedrons right here. Polyhedrons. The matzo balls are... Look at that. How awesome is that? No, I'm expecting something of that quality. Something. Alright. Alright, person. Well, I will decide. Look at the quality and the time.
I don't know.
So I'm giving you enough time so that you can spend good quality minutes on it, especially after the AP is over. I'm pretty sure you'll have a lot more time. In June. That's in June. Alright. So if you're worried about that, don't do it. Alright. What am I doing? No. So, in this website, on this website, you will find the following software which you critically need to know how to use. You don't have to download it. It's a Java app. So, under contents, you'll see Java software. Click on that. Under that, you shall see, if you scroll down, Julia set and the Mandelbar set right there. And let me just override that. So in it, Uh, it's pretty cool. I mean, nothing new, per se, but make sure you go home and play with this, or you'll be asked about this on the test. Not on the cell. So, Owen looking mandible second. Really? So, a different, obvious zoom in and out, there's different color. What do you think this is? Doesn't that look like an orbit? Right? Orbit, right? So actually it's an orbit. Orbit of any seed you choose. So I thought that was pretty cool. So what this is, I mean, this shows simultaneously. Before the previous one, go back and forth. So if you click a point, you know, so that's right. Yeah, it's just. No, it's not obviously. So, and obviously you could do all these points. Zoom out. And you can also zoom in if you want by bouncing it.
No. No.
So now, what would the picture of the Julia said of this point? Now, let's say I give you this picture, which looks connected, but you're not so certain about it. Which I will ask on the test. I will give you a picture of a Julia set, and it's C value. And you have to prove to me that whether that's Julia set is connected or not. How would you do that? Simply, just find the orbit of 0, given the C. And that will tell you if it's bounded, it will be connected. If it's not, then it will be disconnected. Which will obviously not be part of the Mandelbrot set, therefore, it will not be part of the black area. So points like here. Huh. That looks almost connected, doesn't it? Unless I'm clicking on. But it's hard to tell. The only way to tell whether this Julia set is connected or not is by observing the behavior of this orbit right here. Of 0, given the C value, A plus BI. Makes sense, yeah. Why does Julia set being connected between two pairs with not bias against disconnected Julia sets? Julia sets. Why? Yeah. Okay, I like the latter part of the explanation. Because Mandelbrot just decided to form his own set. By what definition? How do you construct Mandelbrot sets? What was his, governing rule of who is in my set or not? Yeah. All C such as Julia said, Julia graph is connected. Well, how do you determine whether the Julia set is connected or not? You observe the behavior of 0. If it is bounded, that means Julia set will be connected. And only those C values are the ones that he's marking with black versus not. Yeah. Uh-huh. Well, I personally do not know the actual application of this particular graph. But once again, the whole concept of dynamic system is used everywhere. But definitely look it up and see, the real applications of Mandelbrot set, and report back to me tomorrow. Because I'm expecting great things from you on that. On this. So that's that. Now, if you actually let me go back, zoom out. Zooming in is fun, but zooming out is also pretty interesting. Back home. Alright. Now, if I hit the orbit button, it shows you the trace. Now, as I fix my orbit near 0, I don't need to do it. I can do it on 0. So this is 0 plus 0i. Boom. Alright? C is 0, 0. Once again, the biggest thing you have to clarify yourself is the difference between seed and C value. Okay? For every C value, you should what? Determine the orbit of every single possible seed. What's the most important seed of all? 0, 0. As you vary the C value, you must test all possible C, including 0, 0, yes.
So the speed of 0, 0 is...
That makes 0, 6.
No, so when the seed is 0, 0, that's when the value of seed is 0 plus 0.
Oh, yes, you're right. But, so Z is 0 plus 0i, plus the C you need to choose. So, on the test, I will ask, let me just tell you. Your test for this chapter will take
Really?
y'all.
So let's just take
Now, but you have to be careful. You will not want to make a mistake. Which hopefully does not mean collaboration. Edward. Still, on the test, what I'm going to ask you is very simple. Using this, you need to choose non-integral value of C. Non-integral value of C such that your Julia set will be pretty interesting. I want to see more Julia set circle. I want you to choose a very interesting C value such that your Julia set will come out to be very interesting. Now, don't. I understand. Don't pick values that are in these big, circles. No. But don't give me that. That's not that interesting. But go like borders of each line. Yeah, something like that. It does not need to be connected. So I'm just zooming in to find something, somewhere interesting. I don't know. And then you need to print it out. And, algebraically prove it to me. Is it part of the Mandelbrot set or not? I mean, the question will be given to you on the list. And also, you also need to try to do everything that I did on Excel. So learn how to do Excel. Now, I've been speaking here. Don't ask your mom about it. I don't think she could help you too much. Or she could probably help you, but... Now, I will give to you tomorrow and on due Wednesday. You got nothing to do. No, the following the day after. Huh? You're gonna hand it in on Wednesday. Wow.
All the way.
It doesn't go that far. So maximum iterations, color cycle, you could do different like rainbow style. You could change the colors.
Maybe see how far it goes.
Different colors. That's not that interesting. Okay, now here is something interesting. Orbit is that, as you see. This shows you if you pick points, it will end up to that fixed point. Now, what if my seed is around here? It goes here, it goes there, and eventually gets fixed over there. Doesn't matter what you choose, as long as you choose your seed inside filled Julia set, it will eventually end up here. Right? It'll take a little longer. Now, what if I choose something not in the Julia set? Maybe like here. That's not. Will that be interesting if I pick a point as a seed here? No, it's gonna. Oh, already. Doesn't obviously it's not going into the black area. What if I choose to the border of the yellow area? So obviously, what did I choose? I chose a point that is inside, right? Infill Julia set. So it probably goes in like this. What? That's just, you know, they didn't bother to compute because they know. If I pick around here, it goes out and then. But if you remember, the largest circle, except the cardioid part, this has a cycle of 2. Prime cycle will be 2, and it bounces between 2 numbers. So if I choose an orbit, let's say even here, it will start and then bounce between the 2 later on. Yeah. What if I choose a green one? It will just go between the 2 later on. Right? What about this one? How many cycles for that one? 3? 1, 2, 3, right? So if I choose that as my seed, it will end up in there. Oh. And if you want to see just a seed, that's what you end up with. Alright? Now, let me zoom in a little. Now, what was this one? Was it 4? I think so. That's 4. So if I choose once again, any point like over there, 1, 2, 3, 4, and you could tell those 4 fixed points. What was this one? It was that. Was this one next one? Oh, no, it's so hard to tell when it gets smaller which one is bigger and so forth, right? What was this? That was 5. So the other one has to be 4 and so forth, right? But what would be that one? Even if you zoom in, like how are you gonna compare that? And you need to compare this with the rest. Or you could count the number of antennas attached to it, right? At the end, right? Or here's an even better one. What was this number here? What was that number? What do you think that number was? 9. How do you... Let's count that. 1, 2, 3, 4, 5, 6, 7, 8, 9.
4 plus 5 is 9.
Wow. Okay. Okay. So that was 9. That's 9. That was... So what do you think next largest one in between? That one? Okay. Shit, like cheated. 14. Ooh. Isn't that a whole lot easier way of counting instead of trying to compare the rest and trying to find the next largest one and so forth? Right? So make sure you know how to do that. Alright, so let's go over the homework I gave you on Friday. Get a hand up. What's it look like?
You're just like,
Song or something?
Yeah. Alright, so let's look at number one. For those, raise your hand if you did this homework. This one on here. Raise your hand if you have this finished. I just gave you nothing. Do it when I give it to you. Do it if you know how to do it. I mean, there's nothing that you didn't know how to do on this page. Alright, let's do it. Number one. Number one, okay. Joanne. Let's do it. Beat the question. Come on. Just answer the question. What is it? Let's see the name of this. Yes! Alright, let it be. Who's here?
No, Z squared.
Very smart. Let us see. Edwin.
what is the name of the large non-circular shape?
Cardio, yes. D, go ahead.
Associated with each flat other point is another set of points. What is the name of this other set?
E.
This is the tape.
No. Yes. Okay, using the C 00 with a value C, which is 0.1, 0.1, iterate until you determine a fixed point of cycle. What is your final result? No. It's not 0. Look, I do not program this with you guys. You finished it. Oh, you better not. What do you get? Finished it, right? If I did it, you should on Excel. No, I did it on TI.
We started to do this.
I'll ask input what? C, input C. No, yeah. And output. And then I have for loop, for x comma 1 comma W if you only ask the user to let them know how many times you want to iterate. If you don't want that, you just set it like 20. And then in the for loop, what do we do? Z squared plus C. Z is from the user. C is from the user. And then set that to store that to Z again. Right? And display Z. That's it.
many iterations? Second. I know second decimal point, but it's I got reused. It's second decimal.
Yep. Point one plus the point one R.
Oh, and then for C, for zero.
Zero.
Yeah.
Someone's talking. Alright. So. Now, someone pointed out, first let's do E first. Does it get fixed to a point? First of all, if you want to determine that, can I use this program to determine whether it gets fixed or not? Oh yeah. Can I type in my C value? Yeah, 0.1 and 0.1. And if I see that the graph of the Julia set is connected, then I know the orbit of 0 for that C value will be bounded. So you know it will get fixed. Whether it will get fixed periodically or fixed to a point, I don't know, but I know it's not. I know it's bounded. You could utilize this program to, confirm that. So if I actually type this in, 0.1 and 0.1. I see that it's that one right there, which is obvious that it is bounded. What is the approximate value? Yeah, well, if I want to find that, I could also do the following. Watch this. On the Julia set, do you see the little box right here, X and Y? If I move that to the green, is it about 0.085 and for the real value and imaginary 0.125? Close enough, right? Close enough. Obviously, that's not exact, but you get an approximate value. So you know that's fixed. Well, here comes the problem. Letter F. Redo problem letter E, but use different C value. -1 -1, and what? 0.1? Okay, we're keeping the 0.1. Bam. Now, from that, it's also obvious that it is connected, therefore it will be bounded. It doesn't get bound to a fixed point, but it's periodic, eventual periodic. Now, the question says, the question only asks you to iterate until the orbit gets fixed or becomes cyclic. So, if you use your program to determine, you probably won't be able to determine whether it is cyclic or fixed. Because it only gives you the end result, meaning the final value. It doesn't give you repeating two numbers. So you might want to modify your program. How would I modify a program? Instead of displaying your answer at the end, why don't you display your answer every time there is an iteration inside a full loop? Oh, if I were you, I will let it spit out. So I don't want to press enter 20 times. And I'm only interested in last couple. Make sense? So if you do that, two values you get fixed will be around 0 and -0.095 something, or some, along the lines. You keep zooming out. We cool? So number 2, Rachel. Is that ever possible for C to be I? C is in A plus the other equals a confidence number. Can you plot that point I on that graph? Just put your finger there. Where will be the I? That is obviously not I. They give you a scale, negative 0.5. I know, but that's not shown to scale. So, is it obvious that I, given I is C, orbit of 0 will be connected? I mean, bounded. Because I, if you look at carefully, this is, right here is about negative 0.75, correct? So, I suspect that will be around positive 0.5 I. So, I will be somewhere around there. So, it's not that obvious as to whether orbit of 0 when C is I will be bounded. Because I can't tell whether it's a member of the Mandelbrot set. Well, you could test it out. I should simply do it. How would I do that? I will set A equals 0 for this. And my B will be, what's B? I? Just 1. Ooh. Yeah. And by the way, you know, lightning is a factor. Did you watch the video? Yeah. Branches out. I mean, that is a perfect picture of a lightning.
What's the video?
Called Hunting for the Hidden Dimension Nova. You better watch that video. That will blow your mind. The whole is Yeah, I asked you to finish it. I could ask questions on the test but on the last 10 minutes.
Okay. Can I make all this Minecraft made out of fractals? 3D